Greetings, beautiful people. Welcome back to Find XYZ. If you are new to this channel, please subscribe. We are still on the road to WASSCE 2026. Let's try this question. We have been given the sides of a right angle triangle ABC as displayed. We have been tasked to do two things. The first thing is to write an algebraic expression in its simplest form for the perimeter of the given figure, and then to use Pythagoras theorem to write a relevant equation involving the sides of the triangle and to calculate for the length of AB, AC, and BC. Let's begin. The first thing is, what is a perimeter? Perimeter is the distance around a figure. And what is the figure? The figure is a triangle. So because the length of the triangle was given in terms of P, we've been tasked to write an algebraic expression. So what we are going to do is we are going to put all the sides together. The length of AB is P plus 5 and the length of AC is P plus 2. Then finally the length of BC is 2P plus 1. Now let's simplify this. We have P, another P, and 2P. So in all, how many P's? So that will give us P plus 2P. We can put them together because they are the same. Then we have 5, 2, and 1. We also put that together. So 5 plus 2 plus 1. So what is P plus 2P? How many P's? 4 P's. Plus 5 plus 2, that will give us 7 plus 1, that will give us 8. The perimeter of this figure is 4P plus 8. That is the first part. The second part, we've been asked to use Pythagoras theorem to write a relevant equation involving the sides of this triangle. But the question is, what is Pythagoras theorem? Pythagoras theorem states that for any right-angled triangle, the sum squares of the legs is equal to the square of the hypotenuse, which is the longest side. So Pythagoras saying that a squared plus b squared is equal to c squared. So it means that we are going to square the legs and put them together and equate it to the square of the hypotenuse. So let's do that. We are going to square AB, so we can say AB squared plus AC squared is equal to BC squared. And what is the length of AB? The length of AB is P plus 5, so P plus 5. Then we square this. Then what is the length of AC? That is P plus 2. Then we square that as well. Then this is equal to the square of the hypotenuse. And what is the hypotenuse? That is 2P plus 1 all squared. Now how do you identify the longest side? Now the longest side is always opposite to the 90-degree angle. Take note of that. It is always opposite to the 90-degree angle. So let's go on and expand. So for example, if I have a squared, I can write this as a multiplying a. So I'm going to do the same thing. So I have P plus 5 all squared. I can write this as P plus 5 and another P plus 5, meaning that there are 2. Similarly, I can do the same thing here. So P plus 2 and I write again another P plus 2. Then 2P plus 1. Then I repeat it, 2P plus 1. I'm going to use an algebraic identity to solve this. Now, in algebra, we know that if I have x plus y multiplying another x plus y, this is s squared plus 2xy plus y squared. So you realize that this is identical to this identity, and in place of this I can replace this. So watch this. So I can say the first term squared, that is P, so I'll write P squared plus twice of the product of the two terms. So the product of the two terms will be 2 multiplying, what are the two terms? That is 5 times P, that will give us 5P. Then what is the last one, which is the last term squared? What is the last term? 5, so we write 5 squared. We'll do the same thing to this term, so let me put this in bracket, plus then this term is also the same thing, the first term squared plus 2 multiplying the product of the two terms, which is 2 times P, so that will give us 2P, plus the last term squared. What is the last term? That is 2, so 2 squared. Then the first term squared, which is 2P all squared, plus twice of the product of the two terms, which is 2P times 1, which will give us 2P, plus the last term squared, which is 1 squared. So let's simplify this. So P squared will give us P squared, 2 times 5P will give us 10P, plus 5 squared is 25, plus P squared is the same as P squared. 2 times 2P will give us 4P, plus 2 to the power 2 will give us 4. It's equal to 2P squared. Now if I have AB all squared is the same as A squared B squared, so it means that the 2 is squaring and then the P is also squaring. So 2 squared will give us 4 and P squared will give us P squared, so we have 4P squared for that. Then 2 times 2P will give us 4P, then 1 squared will give us 1. So we are trying to simplify this equation. What can we do? We can put some things together. We have P squared here, we have P squared here. Put them together, you have how many of them? You have 2 of them, so 2P squared. 10P 4p, how many altogether? We have 14p. 25, 4, how many together? That is 29, is equal to 4p squared plus 4p plus 1. Now, because I want this quadratic to be positive, this is what I'm going to do. If I have a is equal to b, is the same as b is equal to a. I'm going to pick the terms on the right hand side and bring it to the left hand side, and the terms on the left hand side I'll bring it to the right hand side. I'm going to change their position. So a is equal to b. So let's assume this is a, this is b. I'll pick the whole of b and bring it first. So that is 4p squared plus 4p plus 1 is equal to, then I'll bring a here, which is 2p squared plus 14p plus 29. Then what can I do? This is what I want to do. I can subtract 2p squared from both sides. So 2p squared from both sides. Then I can also subtract 14p from both sides. So 14p from both sides. Then I can also subtract 29 from both sides. So 29 from both sides. So it means that the inverse of 2p squared is negative 2p squared. The inverse of 14p is negative 14p. The inverse of 29 is negative 29. It means that the terms on this side, everything will give us 0. So we write out 0. Then 4p squared minus 2p squared, that will give us 2p squared. Then plus 4p minus 14p, that will give us negative 10p. Then finally 1 minus 29, that will give us negative 28. Then we can simplify this quadratic by dividing each term by 2, because 2, 10 and 28 are all divisible by 2. So this divided by 2, this divided by 2, this divided by 2, this divided by 2, so that we can have a simplified quadratic equation. 2 divides 2, how many 2 are in 10? That is 5. How many 2 are in 28? That is 14. So we have p squared minus 5p minus 14 is equal to 0 divided by 2 is still 0. This is our quadratic equation. Now we can use the method of factorization. What we do is that since the coefficient of p squared is 1, so 1 times negative 14 will give us negative 14. Then we try pair of factors. That one we multiply, it will give us negative 14, but when we add, it will give us the middle term, which is negative 5. What are they? I can use 7 and 2, but which of them should I negate to make sure that the middle term becomes negative 5? I'll negate the 7. So if I multiply negative 7 times 2, I'll arrive at negative 14, and if I add these two terms, I'll arrive at negative 5. So I can express this middle term as p squared minus 7p plus 2p minus 14 is equal to 0. Now this middle term is the same as negative 5p. Nothing has changed. Then we consider the first two terms and then the last two terms. So considering the first two terms, what is common among the two terms? P is common, so we can factor p out. The p, how many are they? 2 of them. So p is multiplying p. So if I've put one of them out, there's one left. Then 7p, p is out, what is left? 7. Now whenever you are using the method of factorization, the terms inside the bracket should be the same. So it means that this p minus 7 must be repeated again. So let's consider the last two terms. 2p minus 14, what is common? 2 and 14, the common factor is 2. So I can pull 2 out, and what is left inside? That is p. What number should be multiplied to 2 to get 14? That is 7 is equal to 0. So clearly you can see that the terms inside the bracket is the same. Since we are having the same factor, we can put the factorized terms in one bracket, then we pick one of the terms inside the bracket, and everything is equal to 0. So we have been able to write this as a pair of linear factors. Now whenever you have two numbers multiplying to give you 0, it's either one of the numbers is 0 or both of the numbers are 0. But since we are dealing with the side of a triangle, it means that one of them will not be 0. So let's find out. So what I'll do is that it's either this is 0, so p plus 2 is equal to 0. I can subtract 2 from both sides, so I have p being equal to negative 2. Or p minus 7 is equal to 0. I can add 7 to both sides, then p will be equal to 7. But take note, we are having two values for p. Which of them are we supposed to pick? Because we are dealing with the sides of a triangle. The side of a triangle cannot be negative, and the side of the triangle cannot be 0. So we have to substitute these values to determine which of these values is suitable for this type of problem. We have p to be negative 2 and p to be 7. So let's find out which of them will work. Now if we have p to be equal to negative 2 and we have p to be equal to 7, if we substitute negative 2 here, watch something. If we substitute negative 2 on the hypotenuse, that will be 2 multiplying negative 2 plus 1. So 2 times negative 2 will give us -4 plus 1. That will give us -3. Because we are dealing with the side of a triangle, it cannot be negative. So it means that we cannot select this one, right? We can try with other values, but this has shown that this cannot be. Hence, the value of p is 7. So we are going to use p is equal to 7. And when you substitute these values in these expressions, it will help us find the length of all the sides. That is the last part. The length of AB, the length of AC, and the length of BC. So let's do that. Now, since we have concluded that p is equal to 7, let's find the length of AB. Now, AB is p plus 5 centimeters. AB is what? P plus 5 centimeters. So AB is equal to p plus 5. But what is p? P is 7. So 7 plus 5, then that will give us 12 centimeters. So the length of AB is 12 centimeters. Then what is the length of AC? The length of AC is p plus 2 centimeters. And what is the value of p? P is 7 plus 2. That will give us 9 centimeters. Then the last one, the length of BC is equal to 2p plus 1. And what is the value of p? P is 7. Then 2 times 7 will give us 14. 14 plus 1 will give us 15 centimeters. So the sides of this right angle triangle is 9, 12, 15. Watch this. Now this is a right angle triangle. Now let's verify whether this is true, because we are saying that for a right angle triangle, AB squared plus AC squared should give us BC squared. So let's find out. So 9 squared plus 12 squared, will it give us 15 squared? What is 9 squared? 9 squared is 81. What is 12 squared? That is 144. And what is 15 squared? That is 225. Now what is 81 plus 144? That is 225, which is equal to 225. So we have been able to show that the length of this triangle is 12 for AB, 9 centimeters for AC, and 15 centimeters for BC, which is true because the hypotenuse is the longest side, so it's giving us the longest distance. So that is all I have for you for today. If you found this helpful, kindly leave a comment, share this video to all your friends, and I'll be back with another one. Until then, I'm out.